Now, the elimination method is the process of solving for one variable by combining the two equations by addition or subtraction. So let's say you were given the 2 by 2 system, x minus y is equal to -6, and x plus y is equal to 8. Instead of isolating x or y in the first equation, and then plugging that expression into the second equation to solve for the second variable, instead we'll be adding or subtracting the two equations, and by doing so, the aim is to eliminate one of the two variables. So just like the substitution method, there is a bit of flexibility here. You can choose to eliminate x or y first to solve for the first variable. So here, since the x's have the same coefficient, +1, you'll want to use subtraction since x minus x would be 0, thus eliminating the x and leaving you with just y. -y minus y would give you -2y. -6 minus +8 would give you -14. So by subtracting the second equation from the first equation, we got rid of the variable x, and now from here we can solve for y. But instead of subtraction to get rid of our variable x, you could also choose to eliminate the y here, since the coefficient of y in the first equation is -1, and the coefficient of the y in the second equation is +1. Y can be eliminated by adding them together, since -1 plus 1 is equal to 0, thus leaving you with x plus x, which is 2x. -6 plus 8 will give you +2, and from here you can solve for x. Now, one thing to note, you can be given a 2 by 2 system in which the coefficients of your variables are different in the two equations. So how would you use the elimination method here? Since adding or subtracting the two equations as they are written will not actually get rid of either variable. In this case, one equation can be multiplied on both sides in order to make the coefficients of one of the variables equal but with opposite signs. So we have x plus 2y is equal to -2, and -2x plus y is equal to -11. If we were to subtract our x's here, it wouldn't get rid of the x. If you subtract the y's here, it wouldn't get rid of the y's. If you add the x's, it wouldn't eliminate the x's. +1 minus 2 would give you -x. If you add the y's, 2y plus y would give you 3y, so that wouldn't be eliminated either. So when we multiply this equation by -2, we get -2 times -2x, which is +4x. -2 times y is -2y. And -2 times -11 is +22. And now that we've done that, with +2y and -2y, we can eliminate our y variable by adding the two equations together. So you get x plus 4x is equal to 5x. -2 plus 22 is +20. And our y's are eliminated because +2y minus 2y is equal to 0. So now we can solve for x from here. Okay, so there's flexibility. You can choose which variable you eliminate first. You can choose which equation you'll be multiplying times a constant to make the coefficients work like we did here. Let me just clarify from now how I'll be solving these questions in this chapter so it makes it easier for you to follow along. What we'll want to do is we'll want to eliminate x first and solve for y unless the coefficients of the y terms are equal or equal with opposite signs. Okay, so in this case, if you were given this 2 by 2 system, -4x plus y is equal to -19, and 2x minus y is equal to 11. Rather than multiply this equation times 2 so that we can cancel out our x's, we can skip that step since the coefficients of our y's are equal with opposite signs, +1 and -1. So we can eliminate the y's by adding these equations. So in this case, you would eliminate y first. Let's say you were given this 2 by 2 system instead. -4x minus 3y is equal to -7. and 2x minus y is equal to 11. No matter which variable we want to solve for first, we'll have to multiply one of the equations by a constant in order to make the coefficients work. So whenever this is the case, we'll be eliminating x first. Okay, so I just want to clarify so that it makes it easier for you to follow the practice questions that we're doing, so that when you go over it, my explanations line up with yours, since there are different pathways you could take to get to the same answer. But let's now walk through an example together to solve a 2x2 system using the elimination method. So solve by elimination and check the answer. Equation A, 2x minus 9y is equal to 8. And equation B, negative 5x plus 8y is equal to negative 20. So since neither variables have coefficients that are equal or equal with opposite signs, we'll want to eliminate x first and solve for y. So we'll want to multiply equation A times positive 5 so that we get 10x. And we'll want to multiply equation B by 2 so that we get negative 10x. When we do so, 5 times 2x is 10x. 5 times negative 9y is negative 45y. And 5 times 8 is equal to 40. And for equation B, 2 times negative 5x is equal to negative 10x. 2 times 8y is 16y. And 2 times negative 20 is negative 40. So now the coefficients of our x terms are equal with opposite signs. So we can eliminate x by adding the two equations together. So that's step 3. When we do so, we get negative 45y plus 16y, which is negative 29y. And 40 plus negative 40 would be equal to 0. So now that we've eliminated x, step 4, we can solve for y. So we want to get rid of this coefficient, negative 29, in order to solve for y. So we divide both sides by negative 29, giving us y is equal to 0 divided by negative 29, which is 0. And now that we've solved for y, step 5, we can substitute y into either equation A or B. And then step 6, solve for x. So I'll show you that it works for both. 2x minus 9 times 0 would be 2x minus 0 is equal to 8. So 2x is equal to 8. We divide both sides by 2, and we get x is equal to 8 divided by 2, which is 4. If you were to plug in y is equal to 0 into equation B instead, you would get x is equal to 4 also. So negative 5x plus 8 times 0 is equal to negative 20. 8 times 0 is 0, so you get negative 5x is equal to negative 20. Divide both sides by negative 5, and you get x is equal to negative 20 divided by negative 5, which again is x is equal to 4. So the solution to this problem would be x is equal to 4 and y is equal to 0. And now you can check the answer by plugging the xy into the original equations to confirm that x is equal to 4 and y is equal to 0 in both equations. So starting with equation A, 2 times 4 is equal to 8, minus 9 times 0, which is 0, is equal to 8. 8 is equal to 8 confirms that for equation A, x does equal 4 and y does equal 0. And for equation B, negative 5 times 4 is negative 20. 8 times 0 is 0. So we get negative 20 is equal to negative 20, which is true, thus confirming that x is equal to 4 and y is equal to 0 is the solution to both equations. So that is how you would go about solving a system with the elimination method. Let's now have you complete a few practice questions. Solve by elimination and check the answer. Question number 1, equation A, 9x minus 4y is equal to 30. Equation B, 7x plus 4y is equal to 2. Question number 2, equation A, 8x plus 2y is equal to 12. Equation B, negative 6x plus 3y is equal to 9. In question 3, equation A, 2x plus 8y is equal to 6. In equation B, negative 5x minus 20y is equal to negative 15. Pause the video, answer these questions, and then press play when you are ready to begin. Question number 1. Since our y terms have coefficients that are equal with opposite signs, we'll eliminate y first, since we can do so by adding the equations together. Negative 4 plus 4 would be 0, so that would allow us to eliminate y, leaving us with 9x plus 7x, which is 16x, and 30 plus 2, which is 32. So now that we've eliminated y, step 2, we could solve for x. So we want to get rid of the coefficient 16. So we divide both sides by 16, giving us x is equal to 32 divided by 16, which would be equal to 2. So now that we have x is equal to 2, we want to substitute x into either equation A or B for step 3. When we do so, we can solve for y for step 4. So when we plug x is equal to 2 into equation A, we get 9 times 2, which is 18, minus 4y is equal to 30. We can get rid of the 18 by subtracting 18 from both sides, leaving us with negative 4y is equal to 30 minus 18, which is 12. And to get rid of the coefficient negative 4, we divide both sides by negative 4, leaving us with y is equal to 12 divided by negative 4, which would be negative 3. So we get x is equal to 2 and y is equal to negative 3. But if you plug the x into equation B instead, you would get the same y. So we get 7 times 2, which is 14, plus 4y is equal to 2. Now we want to subtract 14 from both sides, giving us 4y is equal to 2 minus 14, which is negative 12. And then to get rid of the coefficient of 4 in front of the y, we want to divide both sides by 4, leaving us with y is equal to negative 12 divided by 4, which is negative 3. So we get negative 3 if you plug x is equal to 2 into equation A or B. You'll get the same value for y. So the solution to question number 1 is x is equal to 2 and y is equal to negative 3. And step 5, check the answer by plugging 2, negative 3 into the original equations to confirm that they work for both equations. So for equation A, 9 times 2 gives you 18, minus 4 times negative 3, which is positive 12. 18 plus 12 is equal to 30, and that's equal to 30. Confirming that for equation A, x does equal 2 and y does equal negative 3. And for equation B, 7 times 2 is 14, plus 4 times negative 3, which is negative 12. 14 minus 12 is 2, and that's equal to 2. Thus confirming that x is equal to 2 and y is equal to negative 3 for both equations A and B. So that is the solution to the 2 by 2 system in question number 1. Let's now have a look at question number 2. We were given equation A, 8x plus 2y is equal to 12, and equation B, negative 6x plus 3y is equal to 9. Since the y terms do not have equal or equal with opposite signs for coefficients, we'll eliminate x first and solve for y. So we'll want to multiply equation A times 6 so that we get positive 48 for x. And we want to multiply equation B times 8 to give us negative 48x. So when we distribute the 6 to equation A, we get 6 times 8x, which is 48x. 6 times 2y is 12y. And 6 times 12 is 72. And for equation B, 8 times negative 6x would give you negative 48x. 8 times 3y is 24y. And 8 times 9 would give you 72. Now the coefficients for our x terms are equal with opposite signs. So step 3, we can add the equations together to eliminate x, and that will then allow us to solve for y. 48x plus negative 48x would be 0, so that cancels out. 12y plus 24y gives us 36y. And 72 plus 72 is equal to 144. So we get 36y is equal to 144. And to solve for y, we want to divide both sides by 36, giving us y is equal to 144 divided by 36, which should be equal to 4. And now that we've solved for y, step 5, we want to substitute y into either equation A or B, and then solve for x, giving us 8x plus 2 times 4, which would be 8, is equal to 12. To find x, we first want to get rid of 8, so we'll subtract 8 from both sides, leaving us with 8x is equal to 12 minus 8, which is 4. And now to get rid of the coefficient of 8, we'll divide both sides by 8, giving us x is equal to 4 divided by 8, which is 1/2, or 0.5 in decimal form. If you plugged y into equation B, you would get the same value for x, 1/2. Negative 6x plus 3 times 4 would be negative 6x plus 12 is equal to 9. And now we'll subtract 12 from both sides, leaving us with negative 6x is equal to 9 minus 12, which is negative 3. And to get rid of the coefficient of negative 6, we'll divide both sides by negative 6 to give us x is equal to negative 3 divided by negative 6, which is 1/2. So the solution to question number 2 is x is equal to 1/2 and y is equal to 4. And now step 7, check the answer by plugging the xy, 1/2 and 4 into the original equations to confirm that it is the solution for both. When we plug it into equation A, we get 8 times 1/2, which is 4, plus 2 times 4, which is 8. 4 plus 8 is equal to 12. 12 is equal to 12 confirms that x is equal to 1/2 and y is equal to 4 for equation A. And now for equation B, negative 6 times 1/2 is negative 3, plus 3 times 4, which is positive 12. Negative 3 plus 12 is 9. 9 is equal to 9 confirms that x is equal to 1/2 and y is equal to 4 is the solution to this system. And now let's have a look at question number 3. We were given 2x plus 8y is equal to 6 for equation A. And equation B, we were given negative 5x minus 20y is equal to negative 15. So since the y terms do not instantly cancel each other out, what we'll do is we'll eliminate our x's first and then solve for y. So we have 2x and negative 5x. So we'll want to multiply equation A times 5 so that we get 10x. we'll want to multiply equation B times 2 so that we get negative 10x. And when we distribute those constants to the entire equation, we get 5 times 2x, which is 10x. 5 times 8y is 40y. And 5 times 6 is equal to 30. In equation B, we get 2 times negative 5x, which is negative 10x. 2 times negative 20y is negative 40y. And 2 times negative 15 is negative 30. So after step 2, we can eliminate x and solve for y by adding the two equations together, step 3. But when we do so, we wind up getting 0 is equal to 0, since our y terms cancel each other out. 40y plus negative 40y equals 0. And 30 plus negative 30 would also be equal to 0. So since we cannot solve for either variable, and we wind up with a true statement, that lets us know that we are dealing with the same line, and thus there are an infinite number of solutions. So the answer to question number 3 is infinite. There are infinite solutions, since these are actually the same line.